Why does the moon look like it changes?
Well, here on Earth, it turns out that we always see exactly the same features on the moon's surface. That's because the moon spins once around its axis in the same amount of time it takes to go all the way around the Earth, about 4 weeks. So the same side of the moon is always facing us. What we see as changes, or phases of the moon, are actually changes in the moon's illumination as seen from Earth. This lunar cycle starts with the new moon, when the moon is in the same direction as the sun. The side of the moon facing the Earth is dark and is lost to the sun's glare. At first quarter, the moon has moved 1/4 of the way around its orbit. At this point, it is at right angles to the sun, and we see it half-lit. About a week later, when the moon is full, it's opposite the sun in the sky. Rising just as the sun sets, its face is now fully illuminated. The moon reaches the 3rd quarter of its orbit in yet another week. From here, the moon wanes to a crescent and will become new again, starting the cycle all over. Since the moon is so far away, it always looks the same to everyone on Earth who can see it. It's located in different places in the sky depending on where you happen to be, but its appearance is constant. Interestingly, if you're in the southern hemisphere, the moon looks to be upside down compared to its appearance from the northern hemisphere. So even though the moon seems to be changing all the time, it really is just a trick of the light. For Ask an Astronomer, I'm Doris Dahl of the Spitzer Science Center.
What causes an eclipse of the moon?
An eclipse is actually nothing more than a shadow. In the case of a lunar eclipse, it's the shadow that the Earth casts on the moon. As the Earth orbits around the sun shines on it and on the moon. But the Earth casts a shadow, just like you do when you stand outside on a sunny day. So a lunar eclipse is what we see when the full moon moves into the Earth's shadow. Since the Earth's shadow is so large, it can blot out the entire moon for as much as half an hour. A lunar eclipse can be seen by anyone on Earth who has a clear view of the moon during the period of darkness. So why don't we get a lunar eclipse every time the moon is full? Well, here we see the plane of the Earth's orbit around the sun, which is called the ecliptic. Notice that it doesn't line up exactly with the moon's orbit around the Earth. The only time the moon will pass directly through the Earth's shadow is when it crosses the ecliptic plane and it is full. At other times, the Earth's shadow will pass to one side or the other of the moon, and there will be no eclipse at all. This special alignment is only possible during the so-called eclipse seasons, which happen about every 6 months. So the next time you hear about an upcoming lunar eclipse, try to find a clear sky to watch it. And remember that what you're actually seeing is the shadow of our home planet falling on the moon. For Ask an Astronomer, I'm Doris Dahl of the Spitzer Science Center.
Why is Spitzer painted black?
Infrared instruments need to be very cold to operate properly, so it may surprise you that an infrared telescope is painted black. Actually, NASA's Infrared Great Observatory, the Spitzer Space Telescope, is painted 2 colors. The side that faces the sun is painted a reflective silver, while the side that faces away from the sun is painted black. The reflective side reflects the sun's heat, allowing the telescope to cool itself down to almost absolute zero. This allows us to see the infrared sky without any interference. But if you've ever been in a black car on a hot day, then you know that black objects absorb more heat than white objects. So why paint half of the observatory black? Well, in addition to being a good absorber of heat, black is also a good radiator of heat. That means that black objects don't store heat as well as their white counterparts. They give off their heat more easily to the surrounding space. By painting the side that faces away from the sun black, It allows the telescope to radiate away any heat that it generates or absorbs. So the black side is actually helping the telescope cool down. For Ask an Astronomer, I'm Dr. Michelle Thaler at the Sort of Science Center.
Why isn't Pluto a planet anymore?
When we ask the question of what is and isn't a planet, we're really just talking about how we define the word planet. In ancient times, we didn't really need a definition. Astronomers noticed 5 star-like objects, Mercury, Venus, Mars, Jupiter, and Saturn, that didn't move around with the other stars, but seemed to wander through the sky. The word planet comes from an ancient Greek word that meant wanderer. Eventually, we figured out that the Earth is a planet too, orbiting around the Sun just like the others. And that was pretty much it for the solar system until the age of telescopes. The next planet to be discovered was Uranus in 1781, followed by Neptune in 1846. These planets are huge, but just too far away for ancient astronomers to see. But did you know that in 1801, astronomer Giuseppe Piazzi discovered another planet? Or so he thought. Piazzi found a spherical body about 600 miles across, orbiting between Mars and Jupiter. The planet, which is smaller than our moon, was called Ceres. In this case, it wasn't too distant to see, but too small. The problem, however, was that Ceres had buddies. Lots of them. The very next year, a smaller object named Pallas was discovered, and 2 years after that, another named Juno. We now know about thousands of similar bodies. Instead of adding thousands of new planets to the solar system, astronomers decided it made more sense to group these objects together. They named a new class of objects, asteroids, and Ceres got demoted. Something similar has just happened to Pluto. Astronomer Clyde Tombaugh stumbled across Pluto in 1930, but since then, its status as a planet has been called into question too. First of all, Pluto's orbit is strange, wildly offset from the other planets, and even intersecting the orbit of Neptune. Also, it turns out that Pluto isn't bigger than the Earth, as Tombaugh initially thought. Instead, it's got a huge moon nearby. In fact, some people called it a binary planet or a double planet. And, just like with Ceres, astronomers discovered that Pluto isn't alone. Beginning in the early 1990s, they started finding other objects similar to Pluto. Some, like Quaoar and Sedna, were almost as big. Then in 2005, astronomers announced that they'd found an object named Eris even bigger than Pluto. So, are all these planets? Astronomers wondered the same thing. And in August of 2006, astronomers from all over the world met and finally decided on a formal definition of a planet. Pluto and its buddies didn't make the cut, and now they're known as dwarf planets. But don't be upset that Pluto isn't a full-fledged planet anymore. Instead, think how exciting it is that there's still so much to learn about the solar system, and that science can continue to set the record straight, even when our initial ideas turn out to be wrong. For Ask an Astronomer, I'm Dr. Robert Hurt at the Spitzer Science Center.